Okay, so we're recording, and as you can see here, we have a curve, and we have three integrals from 0 to 2, 0 to 3, and 2 to 3. So let me get my annotate feature out. If I were to simply highlight anything above the x-axis as green, and anything below below the x-axis as red, you see that this is positive area and that's negative area. So if I go from 0 to 2, that's all positive area. So that's going to be the biggest one. If I go from 2 to 3, it's all negative area. That's going to be the smallest one. If I go from 0 to 3, it's a combination of positive and negative area. So it's going to be a little less than the integral from 0 to 2. And that's why the answer is D. So that was all for that one. Most of you guys got that one right. That wasn't really a big issue. The next one was okay. I think a handful of you guys missed this one. So you asked for the meaning of the integral from 4 to 10 of f of t. F of t is a rate. It's in liters per hour. And your dt is kind of like change in time. So this is kind of like a delta t here. So essentially what you're doing is you're doing liters per hour times hour. Those cancel. And you're going from 4 to 10. So you're doing for a 6-hour time frame from t equals 4 to t equals 10. Gosh, that's hard to read. It's going to be this one, the total volume of water in liters. So total volume, it's not a rate, from 4 to 10 p.m. Somebody said the total volume for the first 10 hours, but it's from hour 4 to hour 10. So it's only for a 6-hour time frame. So be careful about that. And it's not a net, it's not a rate of change or a net change, just the total that we're dealing with. So remember, it's the antiderivative, right? That's what integral is. So it's not a rate, it's actually the opposite of rate, it's a total change. It's kind of like if you have velocity, do the integral of velocity, that gets you the distance you travel, right? During a certain time frame. This here was that saying which of the following is an antiderivative. So it's not the general, if there's a general rule for an antiderivative, you need to put plus c, but which of the following could be an antiderivative? And of course that one could be. The antiderivative of secant squared is tan, antiderivative of 2 is 2x. I don't think anyone missed this one. You never got this one right. This is why it's good actually I graded in the morning of class, because now it's all fresh in my head. So I'm going to try and make that as a habit. I'll do that next Monday as well. Here, I think a handful of you guys missed this one. Remember, this is reversed. So if you go from negative 10 to 4 of g of x dx, now it becomes positive 3. And here they're asking from negative 10 to 6, which is the whole enchilada. So negative 10 to 4 is a portion of it. 4 to 6 is another portion. The whole thing is this, is this right here. That's the whole thing. So that's just simply going to equal the integral from negative 10 to 4 plus integral from 4 to 6. I'm getting lazy and not writing the g of x dx. So it's 3 plus 5, so just get 8. That's all. If you missed it, if you showed your work, and I could see that, oh, you actually just mixed something up, that probably gave you 4 out of 5 or 4.5 out of 5. So these were worth 5 points. But of course, these got doubled because I made this test out of 100 points. So again, if you missed like 2 questions, got 8%, don't worry. If those 2 questions are careless mistakes, and I gave you like 4 or 4.5 points out of those 5, then you got a high A. So don't worry when the test score looks low. I go back and I look at your work. As long as your work is legitimate, makes sense. I'm going to be very generous with the partial credit. Absolutely. This one's a tough one. I'd say about half of you guys missed this one. Then remember, average value is this, from negative 2 to 4 of f of x dx, but multiplied by the difference of 1 over b minus a, the difference of b minus a as a reciprocal. So it's 1/6 times all that junk. And a parent of that equals 12. You're told that. This is what you have to do. You got to multiply both sides by 6 to get the value of the integral on its own. The integral of negative 2 to 4 of f of x, well, that's not so bad now. That's 72. And guess what I'm asking you to do here? I'm asking you to take the integral and divide by 8. So you can pull out the 1/8, write the integral, and I know that the value of the integral on its own is 72. So the answer is just 1/8 times 72, or 9. And that's all. Interestingly, a couple of you guys put 9.00. I didn't ask for you to round. So if I don't ask you to do something, don't do it, please. Because the way I put it in Schoology, I put just 9. So if you put 9.0, don't worry, I gave you 5 points. I gave you all the points back, as long as your work was fine. But the system will mark it as incorrect because you didn't put it exactly like the way it's supposed to be in Schoology. So just be precise, but not a big deal. I do take care of you. Of course, on the College Board, I mean, I know you're supposed to upload your work, and they actually look at your work when they do the online if they do the online version of AP. But in Schoology, it's not as sophisticated, so it will. I can't really give it artificial intelligence. I think you could do a partial match, but I don't know what that means. So I give it an exact match, and then myself as a human being, I'll look and see. Oh, okay, you just put 9.0, and I'll give you those points back. Okay, this one here. This was a tough one. This one does require a little more critical thinking, and I'm going to put 1 or 2 problems like this. And the next test will be designed the same way. It will be 10 questions designed just like this, and test 4 will be designed the same way. Okay. What do we do here? Well, here's what you got to do. Look at your notes. If you go back to your notes, let's look at the 6.2 notes. Lecture notes, 6.2. Look at the filled out notes. So again, your notes are your best friend. Remember, I said this was very important. This right here. Remember, the definite integral is defined as a Riemann sum with the limits n approaching going towards infinity. So if you are told, so you had to make that connection. Without that connection, you're lost. You had to make that connection. Okay, the right Riemann sum of this integral is expressed with that expression. Great. So this means that the limit of this expression as n approaches infinity is going to equal that integral. That's what you had to do. Yes, the integral itself is an approximation. Like, let's say n is 5 or 6 or whatever. But when n is approaching infinity as a limiting case, that is a definite integral, and it's in the notes. It was right there as we covered it. But yes, you had to make some sort of connection that wasn't really visible. But that's part of critical thinking. That's what you got to do. Then fine, how do you do that limit? Well, you got to go back and look at your fall semester stuff. Remember, everything we've done in the fall doesn't mean I can't assess it. Calculus builds, but this is a much different other classes. Everything builds upon itself. This is not a discrete class like statistics or psychology or other stuff. You got to be able to utilize your old stuff too. So if you were to go back to the fall, and we've done this limit before, so you should know it. If you look at 2.2, remember we're talking horizontal asymptotes and rational functions. When n, or you could just plug in your calculator too if you wanted to, plug in a big number for n or to graph it, you've been fine. But remember we talked about these cases here, right? As n's approaching or x approaching infinity, if the degrees are the same, that's the ratio of the leading coefficients. Well, in this case, the degrees were the same. You get 6n squared up top, n squared down below. That's what answers is 6. So that's it, sort of that one. Yes, you can do test corrections. Test corrections will be due this Friday for both test 1 and test 2. I will actually meet with you guys individually and talk about when I give you guys your feedback. I'm hoping to do that around like 10:20, 10:30 when you guys are doing in a breakout session. I will mention that, and I'll put it as a deliverable in Schoology. I just haven't created it yet. It won't take me long. I'll do it maybe after class is out. But yes, you can do test corrections, totally. Keep moving. Number 7 is a little tricky also. I think many of you guys got it. It was a little weird, but you're told that this equals 0. Now, somebody put 0 as your answer. Well, then, B is 0, right? Because that is true. If you integrate from 0 to 0, yeah. You got to pay careful attention to detail. This class is probably the most detail-oriented class, one of the most you'll ever take. This and probably computer programming, I would say. It's funny, my wife usually bugs me about why it takes so long doing my works, or like why I'm so detail-oriented or OCD. By nature, you have to be. And that, as part of my data science work, I do some coding in R and Python. And if you have one little thing, one little piece of code off, the whole thing fails. You get an error, right? For those who do computer programming, you know what I'm talking about. So you got to be precise. Pay attention to detail. Sometimes I would argue that math people would make great attorneys because they really read the fine print. Let B be a positive number. 0 is not positive. So 0 would not be okay. If you put 0 and didn't show me any of the work, I only gave you 1 point out of 5, unfortunately. But you could do a test correction here, get some points back. So what could you do? And by the way, if you got 1 out of 5, that was worth 2 out of 10 in the grand scheme of things. So I'll give you some points back, so you could get 4 points back towards your test. So it's definitely worth your while to do the test correction if this is the only one you missed. I would still do it. And by the way, the test correction, I'm going to be open to everybody, not just those who got less than 80%. If you even got above 80%, we'll make it open to everybody, so everyone could get points back. But let me clear this again. So again, we want the area to be 0. So this is obviously positive area. Let me get a highlighter out. This is positive area. And of course, this is negative area. I don't know how far to go with this though. I don't want to go too far because then the area won't be 0, it'll be something negative. Then the red area is bigger than the green area. So I gotta find the kind of that sweet spot, just enough so that these equal each other. So if I call this A1 and call this A2, A1 plus A2 has to equal 0. I need those to cancel out. So I need A1 to equal negative A2, essentially. So what you could do is find the area of this guy, which is not hard. That's 1/2, that's 1/4 is a quarter circle times 3 squared, so that's 9 pi over 4. Therefore, the red area has to be negative 9 pi over 4. Or what you could do for simplicity's sake, just keep it positive and use the area of a triangle. What's the area of a triangle? 1/2 times base times height. We know this, right? And it's a right triangle. There's your base. There's your height. The other thing you gotta realize too, this requires a little more critical thing, it's a slope of -1. If the slope of -1, that's me a 45-degree angle. That's a 45-degree angle. That's a right triangle. It's isosceles. Your base and height are the same. And I'm calling this B. That's how far I'm taking the integral to, and that's of course 3. So B minus 3 is my base. My height's also B minus 3. That's 1/2. That's 9 pi over 4. And then you just do your algebra. If you do your algebra correctly, you should get, I think, 3.67. Sorry, 6.67 you should get for B, if you do it correctly. So that was your answer there. Some people put 3.76, meaning they solved for that length, but didn't add 3 to it. Then I could probably give like 4.5 or 4 out of 5 points. And, then for the most part, you had it right. Again, when I go through your test, if I realize I was a little too harsh, I might give you some points back too. I don't take points away unless it was something I really did that was really bad. But rarely do I take points away, so I don't think that's really right to do. Keep moving. This one's not too bad. It's a right Riemann sum. Interestingly, some of you guys did this. Some of you guys did 3. I didn't ask for a right rectangular sum, by the way. Right Riemann sum. Again, attention to detail. Some of you guys did this 3, and then you added 450, 900, 2100, and 2400. Here's the problem. The width of each of these intervals is not 3. That's 4, and that's 2. What you had to do is you had to actually compute each of these widths separately. 3 times 450 plus 3 times 900 plus 4 times 2100 and plus 2 times 2400. If you made that error that I just talked about, I think I took off a point or maybe 2 points, maybe. I might have taken out 2 points actually, because that is a big part. Actually, I think I took out 2 points if you made that error, because I wouldn't say that's careless. That's a misunderstanding of the concept. Oh, some of you guys put games. Some of you guys, the answer is 17,250. Some of you guys put the units, and that's great. I'm actually glad you did that. I didn't tell Schoology to do that because I was just afraid that what if you wrote like games incorrectly or capitalized, what if it was case sensitive. So don't worry, I gave you the points back. So that was one of those examples where, yeah, Schoology is just not intelligent enough to distinguish, those kind of responses. This one here, I don't think anyone missed this one. I think everyone got this one right. Maybe one person missed it, but the answer is 190, just a left Riemann sum. So 25 times 4, 5 times 6, and 20 times 8. I think most of you guys saw that these widths were different. Maybe this was a little more cryptic because it looked like they were equal intervals, but not. So I did that twice just to give you guys enough practice there. And this one was 1.73. So many of you guys missed this problem actually. Didn't because you didn't understand it. It's just that you didn't quite follow through, you didn't execute correctly. Remember, mean value theorem for integrals, not derivatives, means f of c equals this. That's what, oh, sorry, equals average value, my bad, equals that. So that's what you got to do. Some of you guys forgot about the 1 over b minus a part. You forgot that. So remember, you go to your notes has it. Maybe it was under 6.3. Let's go back. Yeah, that's it. So what many of you guys forgot about the b minus a part. So you gotta be very mindful about it. If you do it correctly, you should get √3 or plus or minus √3. You can't do negative √3 because it's outside your interval. And I did ask you to round. If you just put √3, I think I gave you 5 points back. If I took out points, let me know. If you put plus or minus √3, then I probably took off a point or half a point. If you didn't round correctly, I think I still gave it to you. But if I didn't, maybe I'll when I review the test with you in person, maybe I'll give you a point back or half point back. So just be careful. So the answer was 1.73. And again, it's hard to type square root, and it's just easier for the system to accept that. So make sure you just read this carefully. I tried to put in bold and caps and underline it. I'm not sure how else I could tell you how to express your answer, but don't worry. I'm pretty forgiving if you make a rounding error or something like that. So cool. Okay, so that covers the test. So at least I'm glad I did that while it's still fresh in your head. So maybe when I do meet with you individually, it probably won't take as long because you could, yeah, Mr. I understood what I missed. Okay, and then maybe just talk a little bit about your specific error and then we move on. Again, that's done. Okay, I feel like I've talked about million miles an hour. So now let me stop this recording.